This is section 3.1 continued, so you guys should already have all of this down. That's another reason why it went by fast, you guys, is we didn't do any of that stuff because we had already done it on the sheet before. We talked about these two graphs, their domains, ranges, the y-intercept, increasing, decreasing, horizontal asymptotes, whether or not it's continuous. Then we talked about these two formulas, and I didn't get to go over a couple of examples with you. So you just need to know that when you are figuring out the amount of money, your balance in an account, and the interest is compounded, which just means, you asked about that yesterday, just means when the balance is being figured, when it is compounded yearly, that just means once a year they're going to figure out interest. They're going to figure it out once a year. When it's compounded continuously, that means it's constantly being figured. I gave you the formulas. Did you guys get all this down? P is principal, A is balance, T is years. Did you get all that?
Mm-hmm.
Yes. Pardon me?
Is this online?
Yep.
All right.
Yep, it's online, yep. So a couple of examples. We talked about this also. Let's slow down and try this again. E is the natural base number, 2.718. And a long time ago, mathematicians figured out that when they were calculating this value, it kept getting closer and closer and closer to this number, 2.718. So that has become a very famous number. It has a value assigned to it, just like pi has a value assigned to it as well. And come to find out, that was actually a pretty powerful number because they can use it. It's a number that they can use to calculate interest when interest is being compounded continuously. So what you guys need to be comfortable with is how do you use this? How do you use E on your calculator? And we had talked really quickly yesterday about all you had to do was type into your calculator second ln. Sorry, second ln. So if you are calculating f of negative 2, all you're doing is taking e and putting it to the negative 2 power. So in other words, we're using this function rule, e to the power of x. So you are taking e and putting it to the power of negative 2. Remember, e is a number. E is 2.718 approximately. So all you're really doing is putting 2.718 to the power of negative 2. Can you guys help me there? I can't remember what we came up with. 0.1353. Thank you. 0.1353. All right. F of 0.4. That means e to the 0.4 power, which really means 2.718 to the power of 0.4. I can't remember. What is it?
1.49.
1.4. 1.8. Thank you. All right. And I don't necessarily need you to give me 4 numbers after the decimal all the time. If you give me 2 or 3, I'm fine with that. Yep. F of negative 0.5. That just means you put e to the negative 0.5 power. Help me out here. What do you get?
0.606.
0.606. All right, thank you. So, probably not a big deal. All you're doing is pressing second ln and then raising it to a power. All right. Examples, and this is the part that we did not get to yesterday. So make sure you get these down. You have $6,500 is being invested for 7 years at 2.6% compounded quarterly. So write that information down, and we're going to calculate the account after 7 years, the value in the account, the amount of money in the account after 7 years. So you have to decide what formula you're going to use. Are you going to use the PERT formula? Remember we talked about the PE to the RT power is the PERT formula,
No.
like the shampoo?
The first one.
You're going to use the first one.
You're going to use the first one. Why are you going to use the first one?
Because
it
it's
tells how many times it compounds per year.
exactly. How many times is it being compounded per year? 4 times per year. How do you know it's being compounded 4
Quarterly.
times per year?
It says quarterly.
Because it says quarterly. Very good. So the first thing I suggest doing is write the formula down. A is equal to, what is the formula? P times 1 plus
RN. R over N.
R over N to the NT power. All right, so let's go for it. What is the principal? What is the amount of money that was put into the account?
6,500.
$6,500. So we have $6,500 times 1 plus, what is the R value?
Interest rate.
Interest rate, 2.6%. Remember I talked about how that had to be put as a decimal value? I know right now it is a decimal. 2.6 is a decimal. But when I say you need to change it to a decimal, that means you need to get rid of the percent sign. How do you do that? You divide by 100, yeah. Or in other words, you just take this decimal point and you move it 2 places to the left. Are you with me there?
Yeah.
All right. So we have 6,500 times 1 plus 0.026 divided by N. What is N? The number of compounds per year. How many times is it being compounded in a year?
4.
4. All right, so we have a 4 on the bottom. And then you raise that to the power of N times T. Marcus, why don't you answer? It's probably for you. N times T. N is, again, the number of times that it's being compounded. What is T? 7 years. So you are, in this case, going to be raising it to the 4 times 7 power. Good for you?
I like it.
So we have equals 6,500 times 1 plus 0.026 to the power of 4. Did I say to the power of 4? Divided by 4. Thank you. And then this is to the 28th power. 4 times 7 is 28. So now it's just a matter of typing this into your calculator. When you type it into your calculator, you type in 6,500 parenthesis 1 plus, you don't need a separate set of parentheses around the 0.026 divided by 4. Just type 1 plus 0.026 divide 4. Finish your parenthesis, raise it to the 28th power. What do you get? Jacob, what do you get, guys?
77,002. Wait, 7,792.
7,792
92. .90.
and 90 cents.
Yeah.
$0.9
Yeah.
dollars.
That's
Yes. Need a binder.
Damn, that's what 7,000.
Oh, you know what? Here, you guys can have this.
That's every what? Every 3 months?
Oh, you do want
3,
that
6,
thing. All right, another
9,
example.
12.
Yeah.
So they get 7,000 every 3 months.
No, what this means is that if you put $6,500 in an account that is earning interest quarterly, at the end of 7 years, the $6,500 will have grown to $7,792.90. Okay? So, and you guys,
That's not that much.
that's a pretty good way to earn money. I mean, as long as you don't need that $6,500, if you have $6,500 just laying around, if you don't need it, you can stick it in the bank and it will earn that much money. I mean, it's a really good way to make money. Interest rates now are so low that really, they're just not good right now. You're not going to make a lot of money off of just sticking money in a bank account. You will earn money if you invest it in stocks and such. You will earn a lot more money that way, depending on how risky the stocks are. So, all right, are you okay with this? Were you guys able to get $7,792.90 for those of you that actually tried it?
So that's the 7 years,
Yeah,
that's
at the
not
end.
how much interest.
No.
Okay.
If I were to ask you how much interest did you earn, what would you do?
Place the 7 with the 1.
Say it again.
Place the 7 with the 1.
I think
You said what?
Louis is right. He said subtract.
Subtract, yeah. These were, I was trying to figure out what you meant, but yes, you just subtract it. If the 6,500 is what you started with and this is what you ended with, how much money did you earn? You just subtract the two values. Yeah.
And then over the course of 7 years.
Over the course of 7 years, yeah.
Like you said, for
Oh, did I say per year? I'm sorry. Yes, so then your answer would have been right. But then you still would have to subtract. How much did you end with? How much did you start with? Yep. All right, well, let's try the last example. This one, interest is being compounded continuously. When it's being compounded continuously, what are you going to use?
Per.
PERT. Yes, you're going to use the PERT formula. So A is equal to P times E to the RT power. So in this case, A is going to be equal to, what is P? How much money are you starting with? $11,500
Is this US dollars?
US dollars. Yes.
I believe it should be ended with the unit USD.
Times E. Remember, E is a number. What is the R value? It is 0.04.
Yeah.
So here's the decimal point. You move it 1, 2 places to the left.
Yeah.
So it'd be 0.04. Now, you know what? That scares me because that's such a common mistake. So you know what? If you are not very good at moving the decimal point appropriately, take the number and divide it by 100. All right? Type it into your calculator. You're going to get 0.04. So in this case, the R value is 0.04. What is the time? How many years are we talking about?
Continuously.
Um,
Oh wait, never mind. 6 years. Never mind.
0.04 times 6. Alright, so you type into your I probably would do this first. 0.04 times 6. Do that part first. And then calculate 11,500 times E. Remember how to find E on your calculators? Second ln to the 0.04 times 6 power. When you get an answer, let me know. We'll see if we agree.
Miss Morgan, when you do second ln, it comes up as e to the power of.
Yep.
If I'm just multiplying them.
You could stick them in parentheses. The 0.04 times 6, you could stick into parentheses. Yes, you certainly can. So when you type second ln and E shows up with a power next
so
to it,
how do
okay.
you multiply it by 11,500?
Already multiplied. You type this in first. Type in 11,500 first. Then do E. A power shows up, and then in parentheses, you could type in your 0.04 times 6. Or you can calculate this ahead of time and just type in what you're getting here.
So if I just have to multiply a number by the e value, there's no way to do that.
Well, you would do E to the power of 1.
Oh,
You would type in a 1 after it. Okay. 11,500 times E to the, this should be the 0.24 power. So what do you get?
14,619.37.
I don't know how I got that.
$14,619.37. Agreed? Alright, that's it.
Second